Today we'll go over a problem, a geometry problem, given three congruent circles of radius square root of 3. And they are arranged in a way that the edge of each circle intersects the centers of the other two. What is the shaded region? Now, this kind of problem, where you have some sort of circular section, appears quite frequently in math competition sort of problems. And so learning how to solve it will be beneficial into applying to other types of questions. And the key for this problem, for these types of problems, is to connect these radii, these centers, to form this triangle. Now, what's special about this triangle? Well, you can figure out the length of the triangle because you know this is from the center to the edge, so it has a length square root of 3, and that applies to all of them. So you have a triangle, an equilateral triangle with length square root of 3. I'll go ahead and draw that right here. But then we have these other arcs. I'll draw a little arc right here. How do we find that? Well, to find that, we add in this triangle right there. Let me do it in a different color, red. So we have this arc right here. And what's special about this arc is that it's actually the arc of the circle. It's a terrible circle, but so you see, if you look at this circle right here, this arc represents a certain sector of the circle. How much is it? Well, we know because this is an equilateral triangle, this is 60 degrees. So we have 60 degrees out of the whole thing, 360 degrees. So we know that's a sixth of the whole circle. And what that means is if we can find the area of this, which is a sixth of the area of the circle, we can subtract off the area of the triangle, and we can get our little arc here. So now all we need to do is take the area of the triangle and then add 3 times the area of the arc. And that's the area we want. So let's begin. The area of the triangle, of an equilateral triangle with side length s, is s squared times root 3 over 4. And I'll just show that real quick. If we draw a line right here, it's perpendicular, then we have half of s here and half of s here. Now with the Pythagorean theorem, we can find the height. So s squared minus half of s squared, and that's the height squared. I'll call that h. We want to figure out what this height is, so we can simplify this. We have s squared, and then we can have s squared, and then 2 squared is 4. Now we'll make a common denominator. This is 4s squared minus 4. And now since they have the same denominator, we know this is 3s squared over 4. But that's h squared. So now we want to find h, which is the square root of this. And so we can say this is the square root of 3s squared over 4. The s squared can come out to be s, the 3 can stay in, and the 4 comes out to be 2. Now we have the height. The area of the triangle is 1/2 base times height. Well, the base we said was s, so we have the area is 1/2 times the base s times the height, s root 3 over 2. And now we see is s squared root 3 over 4. So now we can come back to this problem. We have this s is the square root of 3. So we can plug this in. We can find the area of the triangle. Square root of 3 squared times the square root of 3 over 4. Well, the square root of 3 squared is obviously 3. And then we have the square root of 3 over 4. Cool. Now we just need to find the area of this circular arc. So we need 1/6 of the area of the circle. So the area of the circle is pi times the radius squared. So we have pi times the square root of 3 squared. And then we divide by 6 to get the arc that we want. 3 squared is 3. And then we have the pi, and over 6, it's pi over 2 is the area. But remember, we have to subtract off the area of the triangle in order to get the little arc. So we have pi halves minus 3 square root of 3 over 4. Remember, that's where we got the area of the triangle to be. And then we'll get a common denominator. That's 2 pi minus 3 root 3 over 4. Now finally we have all the pieces, and we just need to put them together. So we see the area of the triangle is 3 square root of 3 over 4. And then we need 3 copies of the weird circular bit, which we said was this really weird mess, 2 pi minus 3 root 3 over 4. And so then we can simplify this. That's 3 root 3 over 4, plus the 3 gets distributed. So we have 6 pi minus 9 root 3 over 4. And since we have a common denominator, we can combine those. And we get 6 pi minus 6 root 3 over 4. And now they both share a factor of 2. And so we get our final answer to be 3 pi minus 3 root 3 over 2. And that is the answer. And so to recap, what is the important thing to take away from this problem? And is that when you have weird circular areas like this, usually you can try to make a triangle with radii or centers. And if you do, you can figure out that area easily. And then you can subtract off sectors from the circle in order to find the parts you need.